Hello guys, this is Daniel. We have today our second video in the series Blockchain Tricks for the Python Geeks. We are going to be interacting today with an Ethereum smart contract in the Ethereum blockchain through Python. We are going to be interacting with an ERC20 token. Their core ERC20 tokens are Ethereum smart contracts in the Ethereum blockchain. To interact with those contracts, we need a couple of references that we need to take from the blockchain itself. So we need the contract address, which is basically the specific Ethereum address where the contract is stored, and a special type of object, which is called the application binary interface, or ABI. The ABI is a very interesting type of object. It's a JSON object that represents all the functions that the contract has coded. So we are going to do that right now. Let's go to Etherscan. We are here in Etherscan and we have one ERC20 token here, the page one ERC20 token, and one very important ERC20 token as well, the Uniswap token. So as mentioned, we need two things to interact with the Uniswap token in our code. One is the contract address, which we have here. So we are going to copy that one right away and we're going to Visual Studio. Let me just open another file here. We're going to add pyweb3.02.py. And we are going to just create a variable here that we are going to call contract address, and that one is going to be equal to this address that we're copying right now from Etherscan. So this is the Uniswap token. There is the other part that we will need, which is the ABI, the application binary interface. So let's go here, we scroll down and there's a space here that's called contract. And here in contract we have the description of the ABI actually. But let's go to the code of the contract actually to copy the ABI itself. So let's go to here, contract. And here we go to contract, the ABI is here. So let's copy this one. And as you can see here is basically a JSON file that contains all the variables and methods of the contract, all the functions. ABI equal to, and this is not gonna work. This is not gonna work like this, but we're going to leave it like that for now on. So those are the two elements that we want to get from Etherscan. We are going to go back to Visual Studio to start coding our contract. So we are here in Visual Studio Code. We have the information that we pasted from the Etherscan. So we have the contract address and we have the ABI. Now we need to establish our connection to the Ethereum network to actually start interacting with this ERC20 token. For that, we need the node provider. I have something new here that I wanted to touch upon, guys. It's not a good idea to have your API keys directly in your code. I didn't touch upon this one in the previous video because I wanted to go more basic stuff, but we are going to do it right now. So I have this little .env file here. And the structure for a .env file is something very simple. You are going to write the name of your variable, like something like this. Environment variables are usually written in all capital. And then you put equal, and then without a space or anything, you write a value. Here would be the place that you paste your link to your node provider, whatever that node provider happens to be. And then you need to do something else, which is install the Python library. So here we have that library installed, which is the one that reads that .env files. And then we can start using our environment variables. We are going to read that environment variable from the system. So since we are going to read from the system, we're going to do import OS and then the library that we just imported. So we're going to do from .env import lot.env. Then that's it. The other thing that we need to import is our Web3 library, right? So from Web3 import Web3 capital. We need to check everything that to establish our connection to the Ethereum network. So we're going to do lot.env, and this one we just close it like this. This is going to basically load all the variables that we declare in our .env file to the environment, and then we are just going to assign that environment variable to one local variable here inside of our script, inside our module. So we're going to do not provider, which is what we were doing before in this series in the previous video, if you remember. But instead of pasting the link to the not provider, we're going to do OS environ, and we're going to do this not provider. The OS environ is a dictionary that comes from this import OS library that we have here. So this is basically the same as pasting the value of your API key there, but it's keeping it secure because you have that value only in your local environment and it's not in your code. Of course, this .env file, you're going to add it to your git ignore when you load it to a public repository. Now let's create our connection. So we're going to do Web3 connection equals Web3 and parentheses, and we do Web3, the same thing that we have been doing in the previous video to create our connections to the Ethereum network, so not provider. And we establish our connection to the Ethereum network in this fashion. So of course we want to check if we're connected. So def are we connected? And this one is going to check if we're connected. So we print Web3 connection and is connected, and that's it. So we have some basic infrastructure here, some basic housekeeping. Let's do a little bit of a testing. So let's go Python, and then let's import our little module here. We import everything there, and then we go, are we connected? And we are connected. So we're going to interact with this ERC20 token, which is the Uniswap token. So we're going to first of all exit here, exit. We clear our console, and then we are going to go to Uniswap. So here, Etherscan, we have displayed the Uniswap token information. We have some functions that are available as part of this ERC20 token contract. So we have the balance of, this one is an interesting one. So this one takes an address and will return some balance that that address has in Uniswap tokens. And we have the total supply. And since we're going to use the balance of, and that one takes an address, so we're going to go and copy one of these addresses here. We're going to use it later. So we're just keeping that one there. So let's copy that one. And let's go to our Visual Studio Code. So first of all, let's just keep this one as a note here. We are going to use it later to call it, and we are not going to have it there. This is gonna be something that we're going to comment. We're going to use it when we call our function, but it's not part of our code. Now, let's do something here. So we're going to define two functions. One function, it's going to be to retrieve the supply of an ERC20 token. In this case, is Uniswap. So for that, we're going to create one function, and the other one would be a function to get the balance of Uniswap token in a specific Uniswap address. So we go def supply ERC20. This one is not going to take any parameters, and we're going to do contract, which is going to create a contract object. And that contract object, we are going to create it through the Web3 connection object that we have not used there, which is contract. And this one takes an address, which is going to be the same as the contract address, and takes an AVI, which is going to be the same as the contract AVI. So great, those are the two parameters that this one takes. So with that, we create a contract object. So if we want to get the supply of a specific token, in this case, because the Uniswap had that function in their ERC20 contract, we are going to go web connection. No, not yet. We're going to get contract, which is the actual contract object that we created, functions. We are going to get the total supply, which, if you remember, is one of the functions that we got. We're going to do call, which means that we are going to call these other functions inside Python. So this one is a call to the ERC20 contract, and this is a call to that contract in Python. So it's a little bit confusing there, but bear with me. So basically, you are calling the function, but this call is the actual Python function that will give you the value. We are going to get it there, and then we are going to print supply token. So this is the first of the functions that we're creating. Now we have a little bit of housekeeping still to make. Right now, this contract address is copied as a string, and that might have some problems when interacting with the Ethereum network. So we are going to do the following. We're going to do Web3. Now the connection is the Web3 library, and we're going to call this to checksum address. This is going to basically do a transformation in this string to actually make it more like machine code. Now that we do that, that's going to be the proper way to interact with, to put that address as a parameter for this function that we just created here. The other thing that we need to do is that, if you remember when I described what the AVI was, the AVI is a JSON object, but here it is a pure string. So we need a little bit of help here to actually translate it to a JSON object. So that's the reason I left that space there. We need to import the JSON tooling that Python offers, and then we can transform this one with a JSON loads command. So let's do that. It's already between the quotes. So we're going to mark it till the end and add parentheses here. So that will allow us to keep the AVI in the format that we needed as a JSON object. So that should allow us to interact with this contract. So let's check it out. Let's do Python. Let's import everything. And now let's call the supply ERC20 function that we just created. And if you look at this result, it's very obvious that there's something missing, right? We have this funky number over here. We need to transform this response that we're getting with the 18 decimals to actually only the integer part. We need to do something here very, very fast, which is doing the Web3 connection from way. This is a function that we just can have access very, very seamless. So that's it. We save, and then let's do it again, all our testing material. So we go and we get the supply ERC20. Oh, yeah, I forgot something here. We forgot to add that we are passing the value of the supply, but we want to tell him what we want, and we want Ether, because the stroke of Ether is exactly the same as Uniswap, or vice versa, actually. So we're going to clear it. We're going to go again. And here we are. We have 1 billion Uniswap tokens. That's the total supply of Uniswap according to the contract. Let's create our next function, which is to get the balance of an ERC20 token from a given ERC20 token address. So let's do that. We are going to define a balance ERC20. This one is going to take one argument, which is the ERC20 address that we want to pass as an argument to know what is the balance of that public address. Now, if you notice, that's the reason we copy this address here. This is the address that we're going to use. We copy that one from Etherscan. Now let's do ERC20 address equals, and if you have been paying a very careful attention, you know what I'm going to do. Exactly. We are going to do the same thing that we did to the contract address over here to this address that we're passing as a parameter. So basically, we're doing a reassignment of this variable to itself to have it as ERC20 address. Here, passing as a parameter to this one, and then we reassign it to itself. So that way we have the address in a machine-friendly format. Now, what we need to do is something very similar. We need a contract object, which we create exactly with this contract code that we have here. So we're doing actually the same. And the way that we that we get the balance is actually quite similar here. So we're going to do something very similar to what we did in the previous function. Instead of supply token, we are going to call this one balance token. And this balance token is going to be equal to getting from way this contract functions total supply, but we are not going to call that total supply address. We're going to call the balance of, which we know it exists because of the AVI that we just checked out. And we are going to pass to that one one ERC20 address here, which is this one, ERC20 address. So we're passing that one as a parameter, and we call it, so we get the balance, and we get that one. We say that we want to get only the integer part here as Ether, because Ether and Uniswap have exactly the same decimal points, and then we print a balance token. So let's go to that one. Let's do a little bit of a test here. So let's go Python. Let's import everything. And we are going to call this balance ERC20, but we are going to pass this address that we have over here that we brought from Etherscan. Here is commented because it's not doing anything in the code. It's just a way to keep it close to us here. So copy the address and we get the balance. And in this specific address, there are 67 Uniswap tokens. So guys, in this video, we covered quite a bit. We explained a little bit of how an ERC20 token works, the basics. We learned a little bit on how to use environment variables to hide things such as your API keys in the code that you might post into a repository. And we started interacting with ERC20 tokens. I hope that this has been useful to you. Please remember, smash that like and subscribe to the Morales channel, and also keep posted on this series on blockchain with Python. Thank you very much. This is Daniel. Until the next video.